how to configure one timers, and what is how to configure user transmitter, and how to configure interrupt. So everything we have been discussed, okay, on that day, previous days. Today we are going to be discuss about the ADC one. So in this level one, you simply understand about the interfacing concept. So how to interface timer with this one. Okay, so in this level one, you're going to be learn about the concept is, so how to interfacing the things. Okay, if you are having a microcontrollers and along that you are having a timer. Okay, this is your STM32 microcontroller, and this is your any other timer or interface. You just simply take it. Okay, so in this case, you just learn about the interfacing those things. And in level 2 projects, we are going to be add on some other timer plus UART plus any other thing we are going to be add, and we are going to be make it some complex project. Okay, so this is what we are going to be learn on this complete project section. And basically we are going to be take the concept project of configure ADC one register manually display analog voltage over UART. Okay, so before going to be do this project, thank you, Thirumal. So thank you for the acknowledgement. Audio clear. So guys, before we are going to be do this project, I'm going to be explain what we are going to actually do this in this project. Okay. So first of all, I'm just telling you what we are going to be, what is the main thing we are going to be do in this project is, so we have to be take one analog device. Okay, so analog ADC, analog to digital converters, any sensor you are going to be take, so or any modules you are going to be take. Okay, here I'm having STM32 microcontroller, and here I'm going to be having a receiver. The project which we are going to be do is, so here I'm going to be take one ADC. What it is ADC. Okay, so like here I'm just using a pot meter. Pot meter. So pot meter is one of the adjustable resistance. Like here, this STM32 is the microcontroller. I told you like here, I told you like you are going to be display the analog voltage over UART. Okay, some data you are going to be transmit. So some data, so the analog voltage data you're going to be display over UART. So that is what you're going to be learn on here. Okay. So that means configure ADC one register manually. So where you're going to be use this ADC one? Definitely in STM32 because it is having a ADC. Okay, but the module which you are going to be using a pot meter. Okay, what we are going to be do is this pot meter. You might be watch this. You might be saw this pot meter previously. I'm going to be show it again for you. Yeah, guys. So this is the pot meter. Okay. So pot meter means it is a 3-terminal resistance with the sliding or rotating contact that forms the adjustable voltage divider. Okay. So what this mean by pot meter is the pot meter, which is nothing but it is a adjustable voltage divider. For example, this pot meter, it is having a 3 pins. It has having a 3 pins. This one is a 5 volt. This one is a ground pin. Center is the data pin. If you just look out this video, it is an internal structure. One is a input. That means VCC. Another one is a ground. Center is a wiper. Okay. How it is actually going to be look like this? It is having a 3 pins, right? So 1, 2, 3. In this scenario case, so one we have to connect with the 5 volt high power supply, 5 volt, 3.3 volt. You might be connect with that. And another one is you're going to be connected on the ground. Okay, this is how you have to connect with the microcontrollers. And center, you have to be take any data pin. Here we have been choose the port A of 0 because this pin is going to be supporting a analog to digital converter. Okay, so that's what we have been choosing this pin. What it is actually going to be do is here it is already mentioned the thing, the 3-terminal resistor with a sliding or rotating contact that forms the adjustable voltage divider. That means from 0 to, because ground is always 0 volt, which is going to be provided, right? From 0 to 5 volt, you can able to adjust the voltage. Okay, so for example, I'm having a 0 to 5 volt. you can able to adjust like 0.1, 0.2, or 3 volt, or 3.7, 3.3, or 3, somewhat the voltage you can able to change, but that all are in analog voltage. Okay, so that is all analog. But your microcontroller doesn't understand the analog, it does only understand the digital data. Okay, for example, you are having a 5 volt. Okay, so this is the maximum 5 volt. You are just having a maximum 5 volt. This is 3.3 volt, and this is a 2 volt kind of things are there. Okay, this is 4 volt, 4.5. So when you can, if you just simply provide this analog data to the system, then it is not going to be understood. So for that, all your microcontroller having one converter, or else we can tell it as a transmitter, that is called as an ADC. So this ADC is going to be called as an translator. If you people are can't able to understand in any other different language, you are going to be used on translator. Same thing, your microcontrollers, all your microcontrollers are going to be using this ADC as a translator. Okay, so this translator, which is going to be helps to translate the analog to digital data. For example, if I'm just simply given this analog, okay, 0 to 5 volt. So if you are taking a 3.7 volt, for example, 3.7 volt is not going to be read. It is going to be converted into some other digital data. So how it is actually going to be considered? For that, we are going to be use some formulas to be considered. Okay, so here it is, you can simply understand this concept. Here I'm going to be open up the data sheet. Just give me a minute. What I'm going to be doing is I'm just simply open up the data sheet, guys. Okay, in this data sheet, it just clearly mentioned like it is a 12-bit ADC. So this bits of ADC going to be varies by microcontroller to microcontroller. So this STM32 microcontroller, which is having a 12-bit ADC. Okay, how much? It is having a 12-bit ADC. Okay, so some other microcontroller 8-bit, 10-bit, 16-bit, also like that. So if you're having a 12-bit ADC, what is the resolution value is 2 to the power of 12. So you will get 4096. Okay. Uh, yes, it is good for that, but we are just simply reading the data only. So for that, we just taken this one. Okay. So here I'm just simply taken the resolution value of 4096. Okay. So it is also giving the good precision value, guys. Okay, so it is also going to give the precise value, guys, so no need to be worried about that. And the another important thing is, so this is the resolution value. Okay, so in this resolution value, it is going to be varies from this to this. Okay, here I've been show this value called as this. Okay, so what it is actually going to be do is, it is the value going to be changed from 0 to 4095. Okay, so the value is going to be change this to this, because if you are going to be considering 0, 0 to 4095, okay, it is going to be taken this value. So now my thing is also same. Okay, so you don't consider about the module you are going to be using. Don't consider about the whatever. If you're using a temperature sensor, which is going to be supported the analog to digital converter, analog data, because the temperature sensor which reads the analog data, humidity sensor which reads the analog data. So what are the modules which supporting the analog data? That is no matter, but what kind of microcontroller you are going to be using, that is how the very important thing is the what kind of microcontroller you're going to be using in especially, and what is the bit it is having. So it is having a 12-bit ADC. So you will get some good precision value. Okay. In some other cases, you will get only 8 bits. So in if you just taking this kind of 8 bits, it is not going to give that much good precision value. Okay. Why I'm going to tell this it is not good precision value is, if you just see this one, this is the value. Okay. This is the model. I'm just taken that. I've been connected. This is the pot meter I'm just having. So 5 volt, and this is ground, and this is connected with data pin. So this is actually going to be control. If you just turn this towards this, your resistance value reduce. If you turn towards this, your resistance value increase. Based on that, you will get some values, but it is going to be read in digital format. But in the scenario case, you will not get the good precision value while at the 8 bits. Why I'm telling, if it is not good 2 to the power of 8, you will get some 256 bits only. Okay, if you go to this 2 to the power of 10 bit ADC, you will get 1024 values. If you just go to this 2 to the power of 12, you will get up to 4095. If you go to this 2 to the power of 16, you will get some other 16,000 kind of values, above values you will get. Okay, so in this scenario, you must be understand what it is. Whenever the bits is increases, you will get a good precision value. Okay, for example, you are having a 256. Okay, 256 is your value. Okay, in this case, what you will be suffer is your 0 to 5 volt, your 0 to 5 volt going to be shrunk in this 0 to 256. So most of the data you can't get the precise value. Okay, if you go to this 10 bit ADC, you will get 0 to 1023. Okay, it might be slightly good. If we go to this 12 bit ADC, you will get to 0 to 4095. So it is much good, much better. Okay, if you go to the 16 bit, you will get the more precise good values you are going to be get. Okay, so you're going to be get some precise good values you're going to be get whenever you're going to be increasing the bits. Okay, that is very, very important. Whenever your ADC bit is high, your resolution will good. Okay, it is whenever you are increasing the resolution, the value is highly precise. Okay, so you will get the accurate values and precise values you're going to be get. That is what the very, very important thing you're going to be understand, guys. And by the way, our STM32 microcontroller, which is having a 12-bit ADC, we can read the value from 0 to 4095. 0 volt to 5 volt going to be read as 0 to 4095. Here, 0 to 5 volt is analog data and 0 to 4095 is your digital data. Okay, so we don't need to be convert those concept and all because your STM32 microcontroller having one. If you just see this one, here it have been mentioned, it is having a one module. Okay, so STM32 having only one module of ADC converter. Okay, and having the 12-bit ADC. So one module which is contain the 12-bit of ADC will get the resolution up to 4096 or 4095 from 0 to. It is having a 16 channels. Okay, everything we are going to be read and clearly write the code for this one, guys. So first of all, this is, so I'm just open up my code. Okay, you can easily understand this. Okay, so here, okay, so this is the complete code. So what we are going to be do is here I've been explained. Okay, so here I'm going to be collect the data. So here the microcontroller, one pin I've been connected on this 0 ground, and another pin I've been connected on this 5 volt, and the center pin I've been connected on this port A0. I'm going to be tell why I've chosen this port A of 0. Okay, so here with the help of this port A of 0, it is having trim port. Okay, you can able to control the voltage, adjust the voltage. So when I'm going to be turning towards this 5 volt, your resistance value reduce. Towards this, your resistance value increase. So that thing, the data you're going to be collected as a complete data. That data you're going to be received to the another device, that is Arduino, with the help of the UART protocol. So here we are going to be study about two things. One is ADC and another one is a UART. Okay, so from ADC, analog to digital converter, you are going to be made with the help of STM32, and from STM32 to Arduino, we are going to be transmit the data with the help of the UART communication protocol. Okay, so are you people have been got clear this point? Or you people are very got clear about this point? You just clear message on the chat box. You just simply post clear message on the chat box. Right now, we are going to be implement this project. Okay, right now we are going to be implement this project. So simply you just open up your STM32 Cube ID, guys. So if your people have been not installed this STM32 Cube ID in your laptop, please install and practice this one. Okay, so yes, thank you. All the people have been posted got clear. So here I'm going to be teaching everything from the scratch. Okay, you will get easily understand. So in this scenario, guys, uh, uh, can I hope you this black screen is good for you. You can able to see my screen, I think. So I will proceed this. Okay, here the first line. So here I've been returned the thing called as an here I've been returned the thing called as an std int.h. So what does mean by std int.h, which means whenever you are going to be use it in your program, the data types of unsigned integer. Because if you are normally declaring in C program, you are simply use int, right? You have to be simply use the data type called as an int, float. But whenever so white screen is better. So people have been recommended for this white screen. So now I'm going to be change it to the white screen, guys. So I'm also not good with this one because it is not exactly black color. It just faded with some other. Okay, I hope you it's good to view now. Okay, so first of all, guys, this is unsigned integer of 32-bit. Okay, here in most of we have to use an embedded system while you're going to be write any program to a microcontroller. We have to be used called as an unsigned integer. So we are having a two type. One is a signed integer, another one is an unsigned integer. So you most probably you have to be use integer, float, or character in normal C programming. Whenever you're using this int, normal int, it is considered, it's just considering both positive and negative values. Okay, so you can mention, either you can mention the signed or not. It is not giving any problem. Whenever you're going to be use only the positive number, you should use this unsigned plus what data type you're going to be use int. Okay, you never forget to use this unsigned for this whenever you want to use the unsigned type of data type. Okay, it is very, very, very important thing. Okay, unsigned integer you must be used. Okay, for that case only I've been used unsigned integer. For that, I've been declared this header file. So because of I'm going to be use this unsigned integers. Okay, so that's what I'm just simply used this header file. Okay, and in this case, first of all, you just open up your data sheet. So in this data sheet page number 15, so always you don't forget this one because you are having your microcontroller chip. Okay, we know that this microcontroller chip. So if you just look out this microcontroller, guys, STM32 microcontroller, this is the microcontroller. Okay, here it is your microcontroller, right? You can able to see this one, that is your microcontroller. And in this, while you're going to be seeing this microcontroller chip, inside that only you are having all those. You are having all those of what can I say? You are having a timers, you are having a UART, you are having a SPI, you are having a I2C timer and all those stuff. You are having a processor. Yes, yes, it is. So you are having a complete thing. So you're having a processor, you are having a timer, you are having a other peripherals and all which is presented here. Okay, other peripherals are there, and especially the GPIO pins. So GPIO pins is the external one. Okay, you can simply see this one. It is a completely external chip. So this is the external GPIO opens. It is connected with this one. Through that only we just interfacing with everyone because your all the peripheral. If you are taking a UART, one is UART, another one is a timer. Internally, the module will be there, and I2C. So everything has been connected with any of the GPIO open. That GPIO open only you can able to interface with any other modules and all. Okay, this is the flow. And in this case, first of all, I'm going to be use ADC. Okay, I'm going to be use ADC. I'm going to be see where the ADC is there. Here, the ADC is there. Okay, here my ADC is there. So I'm going to be use this ADC one. Why you Charlotte, especially you are using a ADC one? I'm going to be tell you the answer. Okay. So I'm going to be tell you why we are specially using this ADC one. So you are simply seeing ADC one. So for that you are using no. So here I'm just choosing this ADC and I need to be find it out because this is the ADC model. It is having a 16 analog inputs. Okay, it is having a 16 analog inputs and I'm going to be configure that with my pot meter. Okay, for that, I just made the connection. I already made the connection, pot meter, and I've been taken, and 5 volt I've been connected with my microcontroller of STM32 board, and the ground also been connected on this STM32 board, and center data pin has been connected with this pin of port of 0. Okay, this ADC1 has been connected with this port of 0. So how you have been connected that? First of all, you just see this one. This is the block diagram. ADC1 is there, and it is connected with this bus. Okay, you have to be find it out. ADC1 is connected with which GPIO pin? Because I already tell you that whatever the module you have been having, definitely inside this microcontroller, this is your microcontroller. Okay, so inside this microcontroller, all the module has been connected with any of the GPIO pin. Why? Because the GPIO pin purposes you can able to interface with the external devices. Okay, because ADC module is good. If you want to be interface with any other temperature sensor, humidity sensor, you must be required this GPIO pin to be connect with that. Exactly. Yeah. So that's what I'm just to find it out which GPIO pin it has been connected. If you want to be find it out, the same procedure for all the things you're going to be use. Okay. So sometimes the microcontroller also going to be having the same kind of stuffs only. Yeah. You just simply go to this one and go to this pin and the pin definition. Okay. Just simply go to this pin definition. And in this pin definition, what you are going to be understand here it is ADC1, where the ADC1 is there. Okay, you just simply find it out where the ADC1 is there. So here my ADC1. You can able to see that here my ADC1 is presented. So this ADC1 is connected with the port of 1. So that's what I've been choosing the port of 1. Okay, I'm going to be choose the port of 1 here. Got clear, guys? Got clear? Because of ADC1 is connected with this port A1, I'm going to be choose this port. Here, in this case, I have been find it out. My ADC1 is connected with the bus of ABP2 and it is connected with this port A of 1. Okay, this port A, GPIO port A is connected with the AHP bus, AHP1 bus. Got clear. So superb Tirumals and what about others guys got clear up to this point? And again, I'm telling you why we are going to be look out this bus. So your all the module has been definitely connected with this bus because this bus is the one which is transmitting your data with one inside this one to another module. Okay, it helps to be transmitting the data from one place to another place. So that main purpose, the main scenario which is going to be happened by the bus. So the main thing is helps to be transmitting from one module to another module. Okay, I'm going to be give one recap, guys. First of all, you just simply open up the data sheet. Whatever the things you're going to be do. First of all, open up the data sheet. The specific thing is available on your uh, uh, diagram, block diagram or not. Because this block diagram, which is actually going to be telling you the microcontroller which you're going to be using, that specific microcontroller which is having the specification or not. For example, you are going to be use the RTC. First of all, you just open up the datasheet and find out whether it is supporting RTC or not. Yeah, it is supporting RTC. Then you can bring the RTC module and going to be perform here. And another module are just going to be bring it up. UART, or on one any other HC05 module. Okay, you're going to be use HC05 module. HC05 module, it is having a UART communication protocol. You're going to be check your peripheral whether it is supporting a UART. Yes, it is having a multiple UART supporting. You are just bringing any other module which is like what can we say? uh, like ADXL sensor or MPU6050 sensor, it is supporting SPI protocol. You just check it whether it is supporting SPI or not. So likewise, you're going to be check it out. If you want to be configure DMA, it is, you can also do it. Likewise, I just simply check it whether it is supporting ADC or not. Yes, it is supporting ADC. ADC 1 is there. Okay. So for that, I'm just configure this ADC 1. I just already chosen this. First of all, you're going to be check which this ADC 1 is connected with which bus. It is connected with the ABP2 bus. Okay, it is connected with the ABP2 bus, and you're going to be select this one. And another thing is, I already tell you this concept. All the module is definitely connected with any of the GPU open. You are just having this one. You are having an interrupt. You are having a timers and all those stuffs are there. So definitely it has been connected with any of the GPU open. B, A, C, D, A of any of this one, it has been connected with that. You're going to be finding out which GPU it has been connected with that because it is external one, right? So if you just simply having this is your chip, okay, this is your microcontroller chip. And externally, you are having a GPU open. Through that GPU open only, you're going to be interface with any other sensors and any other stuffs, right? So definitely, you're going to be finding out which GPU open that it has been connected with that. So that is very, very important thing. That's what the flow it is going to be goes like. Okay. So now I'm going to be do like I'm just simply write the address. Okay. Here, I'm just simply go to this RCC register, guys. So if you want to be write a code for this, you're going to be use a reference manual. This reference manual is completely help you write your code from the scratch. Okay. So it is simply open up the reference manual. First page will open up, and whenever you want to be configure anything, you're first of all, you're going to be using this RCC register. This is the reset and clock control register. Okay. What it is actually mean is I told you priorly, like you all the thing has been connected with the bus. Okay, it has been connected through bus. So your any other sensors and every model GPIO is connected with this bus. So everything has been connected with this bus. If you want to be enable this GPIO, so you have to be enabled through this bus only. Okay, just giving one clock or 0 or 1. Okay, through that giving those bits, you can able to enable or disabling the complete stuff. So here, what I'm going to be doing is simply I'm just enable this one. I'm just giving one clock pulse, it is going to be enabled. Okay, same thing. If I'm going to be giving one clock to through this bus, this ADC is going to be enabled. ADC 1 is going to be enabled. So if you want to be enable the SPI 3, you just simply give the clock to this ABP 1. Likewise, what are the peripheral has been connected with the which bus, you're going to be enabled through that bus only. Okay, so that is a very, very important parameter. So here I need to be first of all enable and going to be process. First of all, I need to be enable the AHB1 bus. Okay, I need to be enable the GPIO A of AHB1 bus through the AHB1 bus. So for that, what I'm going to be do here, I'm going to be enable my GPIO A through this AHB1 bus. Okay. First of all, I'm just simply going to do this concept. Okay, simply I've been done like this is my HB1 ENR bus. Okay, and in this case, I need to be enabled this HB1 bus. Okay, first of all, I just return the address. Here I'm just simply go to this one. Where is RCC register? Here is the RCC register, and where the AHB1 bus? Here it is the AHB1 bus. This is the address. So I've been written the same address. This is the address. Okay. So I need to be go to the place of RCC register, right? So I'm just simply go to the register of RCC register. Here I can able to see it is AHB1 ENR. So in this AHB1 ENR, I need to be enable the GPIO because my ADC1 is connected with the GPIO. So simply I'm just going to this one and enable this one. How do I enable? With the help of the shift registers? Okay, that's what I just simply write the another function, that is void initialization. So here I've written in a specific function I've been used here. So through that function, AHB1 ENR bus, I'm going to be enable the GPIO. I need to enable this one. I need to enable the GPIO. This bus I need to be enabled here. So for what I'm going to be do, I need to be shift the bit. What I need to do? I need to shift the bit. So how many times I'm going to be shift the bit? Because it is located at the 0th position. Okay. So currently the bit is presented here. When you're going to be shift the bit, it is going to be shifted. Okay. So I need to be I need to be set the bit as 1. Okay. How many times I'm going to be shift the bit? No, it is 0th time. So for that, I need to be set the bit is 1. So for that, I'm going to be shift up to 0th time. So that I've been written out here. So this or operation, okay, this or which represent whenever you're going to be set the bit. Okay, whenever you're going to be set the bit, you're going to be use the or operator. Okay, so what is the consideration of this one? So it just considering this register. Okay, so the pointer here we have been using complete pointer. So with the help of the pointer, I just return the address because the normal integer type cannot define the pointer, that hexadecimal value. Definitely you're going to be using a pointer here, right? Previously we have been discussed that. So that's what I've been declared one pointer name. Okay, here I've been using the address. Here, this is the type casting. Okay, it is going to be integer type of pointer. So after that, I'm going to be dereferencing the pointer. Inside that, I'm going to be using the registers. What are the registers are there? I'm having these are the register. So mostly whenever you're using a pointer, this dereferencing which is going to be tell you like, so inside this register, what are the things that you can able to use this one? That is a pointer, right? So if you are simply you are initializing a pointer, simply this is the address. Pointer of this is the address. X of 0, 1, 4, 5. This is the address. You're simply using a P means you just access the address. But while you're going to use this dereferencing, what are the things which is present inside this register? Okay, you can able to access right now. Okay, that is a dereferencing. So you just simply use it like pointer, that is AHB1 bus. So what are the things which is present in this AHB1? You can easily configure that. You can easily access that. What are the registers are there? GPIOA, GPIOB, all the things we can able to access. So currently it is in this position of 0. AHB1 bits is currently in 0. Okay, your AHB1 bus, which is in currently in 0. You can able to see that AHP1 is currently 0. You're going to be do the operation. Okay, here you just simply understand you're going to be do the operation of or operation of this to this. Okay, so for it is representing, you can able to access all the registers which is present in this AHP1 era. Okay, so what are the registers are there? You are having a register of all those registers. Okay, so all the register currently at the reset condition 00000. In that reset condition, you're going to be OR with the first. It is clearly mentioning set the 0th position of bit. Okay, other bits are 0. If you just do the OR operation with that, you will finally get the value of 001. So you can simply represent 1. 00001. That's it. So you just simply enabled the GPIO-A. Got clear? Okay, simply enable the GPIO-A. And now you have to be enabled the ABP2ENR. That means you have to be enabled the ABP2ENR. What is this ABP2ENR is telling? So this through this ABP2ENR, you have to be enabled the ADC1. Okay, so here I'm just simply go to this ABP2ENR. Okay, in this ABP2ENR, this is the address. Okay, this is the address I'm just having. ABP2 ENR. Here I'm going to be enable the ADC1 ENR. I need to be enable the ADC1. So if you want to be enable the ADC1, I'm going to be use this register. That is a pointer. I'm going to be setting some bit. How it is possible? I'm just simply go to that location. ABP2 ENR. ABP2 ENR, I'm going to be enable the ADC1. So another point is what are the register which is connected with this bus? What are the peripherals actually connected with this bus? Everything is available on this reference manual on here. Okay, so you don't need to be worried about that, whether it is coming, you don't need to be worried about that. Okay, so you will definitely get those one. Okay, and here you have to be configuring the ADC one. We are going to be configuring the ADC one, which is located at the 8th position. So I'm going to be set the bit. If I want to be set the bit, what I'm going to be doing? Here they have been mentioned ADC one is there. If you want to be give the clock to ADC one, you have to be give one for clock disable and zero for clock going to be. This is what the correction we are going to be do it here, guys. So if you want to be enable the ADC, we have to be set the bit as well. So the correction we need to be made. Okay. So the thing is we have to be set one on here if you want to be enable the bit. Okay, so set and reset. So set for to be make it as one, reset for to make it as zero. Mm. Okay, so it is a correction they need to be made. So we have to be uh, we have to don't use for a clock disable and clock disable, both are not same. So if you want to be disable, you just give zero. It is a correction. So if you want to be set one, you have to be set one on that position to be set the clock. Okay, so in this scenario case, I'm going to be set the bit as 1 because I need to be enable the clock, right? So I'm going to be set bit 1. So how many times I'm going to be shift in this bit shift operator whenever what you are going to be set? If you want to be set 3, if you want to be set 4, that is in this left side. How many times you are going to be shift? That is on the right side. Here I'm going to be set 1. Okay, how many in this position of 8th position? So for that, how many times I'm going to be a left shift? 8 times I'm going to be left shift. So same thing we have to be implemented on this position. Okay, okay, that's it. That's it. And the next scenario, I'm going to be set the mode because you just simply enabled the GPIO pin. Okay, this is what the enable GPIO pin is going to be do. Like that, you have been enabled. Now you have to be set what moda through this moda register. You just telling like what application, whether it is going to be act as an input or output or alternative or analog. You are going to be studying for any GPIO open, any microcontroller. For any microcontroller, we are having the specific functionality. The name itself is just having analog, general purpose input and output function. Other than that, you can able to do the alternative, analog, and input. So for that, you just simply open up the mode R register. You just open up the mode R register. Here just simply having a register of moda register. In this moda register, which is going to be tell you that. So what functionality you're going to be doing? Okay. In this general purpose input and output function, you're having those registers. Okay, GPIO is having a lot of register. So why we need to be specially use this moda for here? Okay, each registers has been explained here. So what is the purpose of you are going to be making an input floating, pull up or pull down on analog? So what you are going to be do? So especially this mode R register is for to be set the what functionality mode it is actually going to be performed. Okay, so here the what is alternative function mapping and everything has been located over there. And if you want to be first of all the mode R register, which is especially we are going to be using for the what functionality it is actually going to be used. So if you just see this one, the mode are registered, the bit are written by the software. You are going to be configure input, output, general purpose or alternative or analog. It is for common for all those ones. Definitely you're going to be used. I'm going to be configured as an analog mode because I'm going to be taking the analog data. That's what I'm going to be do is first of all, I'm going to be take the register. Here, you just scroll down, you can able to see the GPIO-A. In this GPIO-A, you can able to see the mode R. Okay, a mode R register. First of all, you're going to be write the address of this mode R. Okay, 40022000. That is the address of the mode R. In that, you're going to be enable the mode R1. Why? You're going to be check what GPIO pin you're going to be using. Port A of 1. 1 means you're going to be choose the mode R1. If you're using a 9 means you're pin 9. It might be port B, port C, whatever it is. If you're using a pin number 9, you have to use the mode 9. If you're using a port number 14, 15, you're based on that, you're going to be using. I'm going to be using a port 1, port A of 1. So for that, I'm just enable this mode R1. Previously, I've been written the address. This is the address of the mode R register. Here, I'm just using this pointer. I've been used this 3 left shift of 2 times. Here, the modas are having a 2 bits. Previously, we have been checked that all are 1 bit. But if you're just telling, they are telling to be set the bit of 1 to be configuring analog. 10 to configuring alternative function like that. Okay. Here I require the 2 bits. Okay. So in the position of mode R1, okay, I'm going to be set 1 on here. So I'm going to be set 1 in the position of mode R1. Okay, so if I want to be set here, how can I possible, how it is actually possible here? What is the binary value of 1 guys? It is 3. 0 means 0. 1 means 1. Okay, 0 means 0, 1. And 10 means 2. 1 means 3. The binary value of 1 is 3. So simply I'm just, instead of using 1, I can use 3. So I'm going to be set at the position of 2 and 3. If it is 2 bit, it's just considering all as being 2 bits. If it is 1 bit, it is considering 1 bit. If it is a 4 bit, it is considering 1 bit. Here it is complete 2 bits. Initially, it is in the position of here. When you're going to be shift the bit, how many times you're going to be shift? It's just considering 0th position. So 1, 2. 2 times I'm going to be shift. So 3 left shift of 2 times. So at the time, this 2 bit is going to be located at this position. Your thing has been completed. Okay. So that's what I've been done. So 3 going to be left shift up to 2 times. So through that, I'm just enable the port A of 1 as analog mode. Okay. And then what I'm going to be do is I'm going to be do some procedure. I'm going to be do some procedure. Today we are going to be only study about the ADC functionality, guys, and tomorrow we will see the user. Okay, tomorrow will, because it is going to be big project. So for that we will continue that on tomorrow. We will complete with ADC alone. Okay, so next I need to be study the complete thing of ADC. Where the ADC is there, the ADC has been presented on here. So this is the ADC register. If you want to be know about more this ADC, you're going to be study this one. So this is the introduction from introduction. So I previously told you I'm going to be use ADC 1 only. Why I'm not using ADC 2 and 3? It is not available. There is no ADC 2 and 3s are there in STM32 F411RE series. That's what the reason I already told you to show them why we are not using. So it is not available. Only they are having ADC 1. Other bits are not there. Other ADCs are not there. Okay. And it is having a 12-bit ADC, which is having a 19 multiplexed channels of 16 external, so it is possible. So this is the data they have been given. You have to be read out the features at all. So what these features are telling is these are the bit configuration, resolution value, it is possibilities are there. Okay. So, and we will see that what is my end of conversion, what is the end of injected conversion. So everything I'm going to tell you right now. Okay. Features. And the very important thing, you have to start to read from here because it helps to write code from scratch itself. First of all, they have been given ADC is powered on setting the add-on bit in ADC CR2 register. That means if you want to be power on the ADC in a sense, you are having a module. Okay, you just see this. You are having a ADC model. For example, this is ADC model. Okay, this is your ADC model. If you want to be on the ADC, okay, if you want to be on the ADC, you have to be use the register called as an add-on bit, which is presented at the ADC2. So for that namesake, I'm just duplicate this file. I'm just go to this CR2 register. Okay, where the CR2 register is located. Here, here CR2 register is there, and inside the CR2 add-on bit going to be enabled. So while you're going to be enable the add-on bit, your complete module is powered on. It is ADC converter on off complete thing. Okay, if you want to be one, it is enable. If you disable, it is go to the power down mode. Okay, so it is in the power down mode. So I need to be enable this one. First of all, whatever thing you have to be register, you have to be manipulate. First of all, you have to write the address. Through that address only, you can able to configuring the bit. I'm just to go to this ADC one. So ADC one is presented here. So in this ADC one, here you can able to see the AHB1 NRS. So in sorry, it is not. It is RCC. ADC one you have to be looking for. Yeah, it is the ADC one. So in this ADC one, guys, we need to be enable the CR2. Yes, right? We have to be enabled for the CR2 register. So if you want to be enable the CR2 register, what I'm going to be do? In the CR2 register, I need to be enabled the add-on bit. Okay, so previously I'm going to be write the address. So simply I'm just putting one name. Whatever the name you can give it. Data type of pointer, I need to be use the CR2. So first of all, I just initiate the address and then I'm going to be set the bit of add-on. Okay, set the bit of add-on. So here I'm just configuring that. How it is possible that one on here. So I can able to see add-on bit is located at the 0th bit. Now, you people are going to be tell the answer. Okay, you people are going to be tell the answer. What I'm going to be set. Okay, how many times I'm going to be shift? I'm going to be to left shift only because setting and resetting completely I'm going to be using a left shift. Here what will comes and here what will comes. Or you people are aware or you people are sleeping. I'm going to be checking you right now. So what value gonna be come here? We will have a test. So what is actually going to be coming on here? So everyone going to be put your answer on the chat box. Okay, Hemandra gave the first answer. And what about here? Then he is listening. Yeah. Yes, Hemandra. So you have been given the answer and Hemandra given the first answer. Yes, exactly, Abjit. So yes, Abjit and Hemandra gave the right answer. We have to be put what? And what will come here? This is the position. What bit you're going to be set? Okay. And this is the position. What value going to become here? Yes. So Hemandra again gave the right answer. Yes, exactly, Hemandra. So this position, how many times? It is not what. It is simply telling you like how many times. Yes, Abjit. Hemandra and Abjit are aware. So they give the right answer 0 because I'm going to be shift the 0 time. So it is telling how many times. Exactly, your answers are right. So that's what we have been did. So add-on bit have been enabled. Okay. And then what I'm going to be do? We will read this right. So after you have been enabled this one, when add-on bit is set for the first time, it is wake up. Your RC ADC bits are wake up. So I'm really giving the great applause to the to those people, A Mandra and Abjit. So given the right answer. So the thing is, guys, yeah. So the thing is, guys, we have to be aware about this one. Here, next thing is telling like conversion start when either the SW start or JSW start. Here, you whenever you want to be start the conversion. Okay, you have to be start the conversion. You have to be enable the SW start or JW start. What does my SW start or JW start means? SW start, which means you can clearly understand here it is a single or continuous conversion mode. Okay, so the JWS start is a single conversion. Continuous conversion, if you want that, you just use this SW start. Okay, here we will study this while you're going to be work on this. Okay, so you have to be use that bit. Okay, it is helps to start the conversion. Okay, you need to be start the conversion. So for that, what bit you are going to be use that, we will study this, and then we have to be enable the ADC clock. So I already done. Okay, I've been enabled the ABB to NR. I just enabled my clock. Okay, and then it is telling like what channel you're going to be use. Okay, here that's what I just tell you that regular group or injected group. The injected group means it is just like it will be giving the single conversion only. Okay, it's just like a single conversion. We have been using the regular group because it's just having a 16 conversions. Okay, we are having using a 16 conversion. We have to be enable this 16 conversion channel through this register. So ADC SQRX means whatever you can able to replace here. 1, 2, 3. Okay. Through that you can use the what channel you are actually using. Okay. I'm just go to this SWT. Just to go to this like this one. I'm not going to be using an injected channel. I'm going to be using a regular channel. Here I'm just go to this SQ3. In this SQ, it's just having one. So why you are not choosing this SQR3, SQR1? So you can ask me this question. Why you are not using SQR? SQR1 are you just having 60, 13, 14. I need to be choose ADC 1, which is connected at the port of 1. No, I didn't require this 14th pin, 13th pins and all. I need the port of 1. So that's what it is in old terminal. So I'm going to be choose this sequence of 3. It's just holding a SQ of 1. Here I'm going to be enable this port. Here they didn't give any bits to be start. So if you want that one, if you want the SQ1, the first conversion in sequence, you have to be simply enable as 1. Okay, it is simply whenever they have been not given the data properly, you're going to be read it from the scratch. Okay, and here I'm going to be give 1. Okay, give 1 to be start the channel 1. So SQ3 means it just simply understand 1 means the channel 1 we are going to be use. Okay, and another thing is you have to be read all those stuff. So they have been simply given the channel details and all. I'm going to be using a channel 1 only. Okay, so that's the complete details. And then single conversion channel. Okay, so whenever okay, setting SW start bit, it is going to be start the regular channel. We already studied that. We have to be implemented on here also. Okay, so JWT means it is an injected channel. Okay, your data is not going to be sequential. Okay, we have to most probably using a regular channel. Okay, and if a regular channel, if you're using a regular channel, if you're using injected channel, we have to use the regular channel. In this regular channel, the final converted data is going to be stored on the data register. Okay, once the end of the conversion flag is going to be set. Okay, once it has been end of conversion flag has been setted, you have to be store the data on this place. Don't confuse it, guys. You just come up with the procedures only. You just move the procedures. Like first of all, I'm just having a add-on. Okay, I'm just reading the reference manual and we are going to be implemented. In this case, simply they have been given if you want to be on off the module, you have to enable the ADC of CR2 register add-on bit going to be enabled. That's what you're going to do. If you want to be start the conversion, you have to be use the SW start. We have to be implemented right now. Okay, and we will start the conversion. Okay, you have to be start the conversion. You have to be find out where it actually located. Okay, where it actually has been located. We have been included that has been here. So I've been enabled that one also. SW start, but has been also enabled. So why you have been returned in this while one? So Another thing you must be understand, guys, in reference manual, they don't give like how you return the code. So that all based on, they simply tell you this bit, if you are setting, it is going to be enabled. This bit, if you are setting, it is going to be start the conversion. Likewise. Okay. But why I'm going to be returning this while one, this SW start means this completely starting the conversion. If you are just on the bit, on means at entire procedure it should be on. That's what I just out of the loop. It is in the complete set. So while one, so if you just completely it is on. Okay, so it is providing some data. So inside this while one, so start the conversion. So while it reaches this loop, it is continuously going to be process is going to be happen. So conversion going to be start once the conversion has been stopped, because you are having ADC analog data that is going to be converted as a digital. Once it has been converted as a digital, again the procedure is going to be restart. Again, it is going to be continuously going to be happens. So that's what we have been written on the loop. Start conversion are going to be start continuously. And the clock itself we have been already configured. Here it's just telling a channel, because in every ADC model, any microcontroller, you are having a channel. Multiple channel you might be having. Not every channel going to be used. Some of the channel going to be used. If we are having a multiple channel, I'm going to be using the channel one. For here it is having a two types of group. One is a regular group, another one is the injected group. Okay, so in this regular group, we are going to be using a regular because we need the continuous conversions we require. If you want that, you have to be configure this register as one. Okay, we already set at that value also. Here only the main thing is coming like SW start bit. We have to be enabled with the help of the CR2 register. CR2 register, just go to this. Here you can able to see that SW start bit. So it is continuously going to be start the conversion and setting the bit. Here I just simply put what we are going to be set 1. You can easily read it. SW start means 1 means start the conversion, 0 means reset 1. So how many times I'm going to be left shift? I'm going to be shift up to 30 times. I'm going to be simply enable that because it is continuously going to be happen. That's what I just use it on the loop. And then final data going to be stored on the DR register. Okay, final data is going to be stored on the DR register. Here, that's what we already studied. Okay, first this procedure has been completed. Okay, and if you just come to this converted data stored into the DR of 16-bit register. Understand, it is completely 16-bit register. I need to make it as a 16-bit data. Before that, I'm going to be store the data while the EOC end of conversion flag is set. What is mean is you are having analog to digital converter. Okay, analog data converted to the digital. For to start, stop, that's what we are doing. Not we are actually converting the analog to digital. Everything is going to be done by your ADC model. So it is going to do all the procedure. It is going to be do all the things done by the inside this microcontroller only going to be taking care of those concepts. Okay, so here we just simply enabling and disabling something only. Okay, just simply enabling and disabling the ADC models. Okay, so this thing we are going to be do. Okay, and here one set of bit you are having. Okay, simply first of all just reading one data, that is 5 volt. Initially it just read one data 5 volt going to be converted as in digital, like 4095, 3.7 volt. For example, it is 2547. This is called as a conversion, digital conversion. So it is converted, it is ended. Okay, once this 5 volt is converted to this 4000, it is ended. So this is what this line we have been written. You are going to be checked because if it is complete, this condition, we can't make it as a condition. We can't make we can't make it as an we can't set the thing like you have to be end the conversion. No, sometimes some problems has been happened to a microcontroller. You can't able to convert the convert the conversion. So at the time, we have to make it as a condition. So while, okay, here, if you just see this one, while in this SR register of ADC, because this EOC, which is present at the SR register, you have to be find it. So EOC, which is presented at the SR register. Okay, so what you're going to be do is the regular channel end of the conversion, which is happened. They also mentioned end of the conversion of the regular channel. It is cleared and reading the data register. Okay, so while this SR register of ADC, we just simply checking the condition of one of left shift of one. That means it is, you have to set one on here, you have to be shift up to one time. So left shift of one. Okay. So when this condition is get matched, okay, you have been written as a condition. You have been using the register called as a status register. You have been just masking with one left shift of one. Okay. When this and this, okay, it is defaultly one, it is 0, 0. Okay, still give 0. So when this register getting 1, okay, if you are setting 1, so when it is make it as 1, the conversion has been ended. And that data, you just simply store it on the DR register. But we are just reading the data from a DR register. Here we are not for to be stored. We just reading the data because once this conversion has been ended, the data going to be stored on the DR register. You can also study here. So the bit is harder, end of conversion, that it is going to be cleared by the and reading the DR register. It is going to be just store. It is simply given the DR register. Yeah, I'm just using the DR register. Okay. And here I'm just using one variable. Here I just declare the variable. Simply I've just given it as a one of the variable. So through that variable, I'm just reading the data. I'm just reading the data. Then why you are using 0 cross FFF? Because it is 12-bit ADC. Even though I'm getting some data, even though I'm just getting some other data, I'm just making it as a 12-bit ADC. For example, I'm just getting 11110000045678. Hey, data I'm just simply getting. I'm just simply masking with one FFFFF. So what it is actually mean that I'm just simply doing this one FF. I mean FFF. So one F, which is, and another F, which is going to be give, another F, which is going to be give. Simply, I'm just converting the normal 8-bit to 12-bit by just masking with this value. Okay, you don't consider about other values. It's just simply masking, even though it is considering as a 0, 0 only while you're going to do the AND operation. That is not matter. We need a 12-bit ADC. We need a 12-bit ADC. I'm just simply making that's a 12-bit ADC. Okay. And the final data is going to be stored on the ADC value, the value, the variable which have been used on here. So from today, we just simply convert the ADC. Okay, here I'm just using